Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Now, we are on lesson 22, which is a review of expressions. So first, we're going to talk about numerical expressions. And numerical expressions stand for numbers. And no variables, they represent a constant number. So let's look at some numerical expressions. 4 is a numerical expression, and its value is 4. Okay, it's what it equals. 6 plus 3 is a numerical expression, and its value is 9. 4 times 2 plus 3 is a numerical expression, and since 2 plus 3 is 5, and 4 times 5 is 20, the value of this numerical expression is 20. And this is a numerical expression, a little bit more complicated, but this is 7 times 12 divided by 7 again. And since I have 7 on the top and a 7 on the bottom, I wind up with 12 as the value of that expression. So now let's talk about some algebraic expressions. Algebraic expressions may contain a variable. They don't have to contain a variable. In fact, all of our numeric expressions are also algebraic, but 6 is an algebraic expression, and it's just a number. Its value is 6. But here, x plus 4 has a variable in it, and we cannot determine its value unless we know what x is. X squared minus 6 is a variable expression. It's algebraic, and we can't determine its value unless we know what our x is. X times x plus 4, algebraic expression, has a variable. We don't know what its value is. But suppose they told us that all of these values of x was 3. So 3 plus 4 would then be 7 when x equals 3. 3 squared would be 9, take away 6 would be 3. So once we know that the value of the variable, then it's no problem determining the value of the algebraic expression. 3 times 7 is 21. So once the mystery is solved and we know the value of the variable, then it's no problem finding the value of the algebraic expression. So there's some examples of algebraic expressions. So now I want to show you in your book. Okay, now we're on the B portion. It says if we wish to make a statement that certain quantities are equal or not equal, we can do so by writing a grammatical sentence in English. The number of peaches equals the number of apples. The number of peaches does not equal the number of apples. The number of peaches is greater than the number of apples. The number of peaches is less than the number of apples. If we use the variables n sub p and n sub a to mean the number of peaches and the number of apples, and if we use the symbols equal to mean equal and not equal to mean not equal and greater than to mean greater than and less than to mean less than, then we can make the same statements. So now that we have numeric symbols, we're going to say the number of peaches is equal to the number of apples. And that's what A said right there. Okay, so then B says the number of peaches does not equal the number of apples, and we can also express that. The number of peaches does not equal the number of apples. And then C says the number of peaches is greater than the number of apples. The number of peaches is greater than the number of apples. And D says the number of peaches is less than the number of apples. The number of peaches is less than the number of apples. So we have to learn how to express our truths, mathematical truths, in algebraic sentences and statements, okay? So here we're going to talk about equations and inequalities. This one is an equation, and the other 3 are inequalities. This lesson is only dealing with equations. We'll be talking about inequalities in a later lesson. Okay, so now an equation is when we take 2 algebraic expressions and we join them with an equal sign. That's what an equation is. So now let's look at some equations. 4 equals 3 plus 1. That would be a true equation, a true statement. So let's just write a T for true. Okay, and let's look at the next one. 4 plus x equals 2 plus 2 plus x. Now remember, anytime we have an x and another x in the same equation, we understand that those two x's are and must be equal to each other because they can't change values in the same equation. So this is an equation because this is an algebraic expression and this is an algebraic expression, and they are joined by an equal sign. So this is an equation. Is it a true statement? 4 plus x is 2 plus 2 plus x. Well, we know 2 plus 2 is 4, and we know the two x's must be equal. So yes, this would be a true statement. Okay, this is an equation, but is it a true statement? 4 equals 6. Well, no, 4 does not equal 6, so this would be a false statement. And then here we have 4 plus some number is equal to 6 plus that same number. And of course, we know the x's must be the same, therefore, this could not be true. This must be false. Here we have an equation, x plus 4 is 8. This is called conditional. Okay, this one was true no matter what. This one was true no matter what x was. This one was false no matter what. This one was false no matter what x was. This one is conditional because it can be made true by only one x. Okay, so we can make it true, but right now we do not know that it's true. If that x stood for 3, then it would not be true. So we're going to find the solution, and the solution for x is what makes it a true statement. So just so that you know, this is called, when we have a true statement, we call that an identity. We call this an identity. Okay, we call this a contradiction. Contradiction. And then we're going to do most of our talking about this conditional statement here because we're going to be solving conditional statements. Solutions satisfy or make equations true. So now we're going to learn to recognize and then to find solutions. Does -2 or +5 satisfy this equation? Now we have an algebraic expression on the left, algebraic expression on the right, joined by an equal sign, so this is an equation. Now we're going to check -2 first. Does -2 satisfy? If it satisfies, that means it makes it true. -2 times -2 would be the same thing as -2 squared. -2 times -2 is 4. -2 times -5 would be a positive 10. -2 does not affect this one at all. That's a constant. Is 4 equal to 10 minus 6? True. Okay, so -2 satisfies. That means it is a solution. Okay, so it is a solution. Now we're going to check 5. And 5 times 5 is 25. And 5 times -5 is -25. Minus 6. So 25 is equal to -25 minus 6? No, that does not work. Okay, 25 is not equal to -31. So this one is not a solution. +5 is not a solution. And -2 is a solution because -2 satisfies the equation. Okay, here we have another question. This is example 22.2. Does -2 or +2, are they roots? Now, roots are the same thing as solutions. So we're going to see, does -2 satisfy the equation? -2 squared would be +4. Minus 3 times, now we're going to substitute in the -2, for the x is 10. Okay, so 4 plus 6 is 10. And negative 2 satisfies, right? So now we're going to check with positive 5. 5, 25, minus 5 times a negative 3. So negative 3 times 5 is going to be negative 15. Ooh, that works too. So both of them are solutions. Okay, we're going to be learning a lot about these x squared guys here. If it has an x squared in the equation as the highest degree, then there are two solutions. And this one had two solutions, negative 2 and positive 5. So both of them satisfy, therefore they are both solutions. They are both roots. They both mean the same thing. So let's come back and do some practices. Okay, this one's pretty easy. Does negative 2 or 2 satisfy the equation? So we plug in a negative 2, get negative 2 minus 2 equals 0. No, that's not true. Negative 2 minus 2 equals negative 4. But if we plug in a 2 here, instead of a negative 2, 2 minus 2 does equal 0. So this one is our solution, and this one does not satisfy. Since our last practice, we're checking to see if negative 2 or negative 5 will make this equation true. Do they satisfy? Are they solutions? Are they roots? All mean the same thing. So negative 2 goes into our little parenthesis first. And then we'll do plus 7 parenthesis negative 2 equals negative 10. So let's check. Okay, so this is going to be a 4. And then minus a 14. And 4 minus 14 is negative 10. And therefore, the negative 2 does satisfy. It is a solution. It is a root. So now let's take our negative 5 and let's plug it in here. And plug it in here. And let's get rid of all this. So we end up with 25, negative 5 times 5, negative 5 is positive 25, minus 35 is a negative 10. And that is true. So we have two roots that we have for that equation, and it's quadratic. So it's allowed to have two roots, and we found them. That is all there is to lesson 22, and I hope you have fun doing your homework. This is Mrs. A, and may God bless your day.